that these are useful tools, right? I think I mentioned that before, Todd, that I really, these first couple of months of class, there's so much foundational stuff that I think people benefit from. Oh, that's weird, Nicole. All right, just give me, oh, I guess you're probably gone already. Just hang on a second, Nicole, okay? Here, let's try this. Is that any better? Okay. Yeah, then I don't know what is going on that you're just seeing black on the screen. I don't know what causes that. Okay. So we had a look at some financial calculator calculations this morning. We've done a fair bit of work there already, and that's good. I always like to put in some real time there. We're going to do a little bit more financial calculator stuff really between now and the coffee break. And then after the coffee break, we're going to come back. Oh, I got it. Okay. After the coffee break, we're going to switch over and we're going to talk about risk. And we're also going to see a little bit of how Excel gets used for time value of money calculations. Now, we actually don't, by design, teach Excel in the course, and that's fine. I do think it's something every financial planner should know, but most don't and most never really get into it. So, and it's not tested, it's not a required skill. So what do you do? All right, so let's finish out the Kevin credit card problem. Okay, and then I've got a couple of other items that we will delve into here. So what if we do the second part now of the Kevin question? Once again, where do we start here? Draw a line, right? So we're going to draw our line. Now, what's on this line? What do I know here? $32,000. Okay, what else do I know? So where does the 7.5% show up here? So it's still, we're still looking at 19.99%, right? Back here, where does the 7.5 show up? Yeah, that's it, right? So that's where, and we can figure that out in a couple. In fact, we did that before lunch, didn't we, Mike? But let's start from scratch again here. So we're looking at 2 years. We're looking at a payment of $650 every month. And we're trying to do what Mike just gave us here, which is to solve for future value. That's good. Okay, so we can do our PY and CY. Those are once again going to be 12. We can do times PY. We can do IY at 19.99. Right, and that's, again, this is where we want to practice some questions like this, Todd, just to get the hang of how we're going to do sort of multi-stage questions or how we're going to think about less conventional problems. Okay, present value is going to be 32,000, payment at negative 650, and future value is what we're now trying to compute. Now, I'm going to give a little piece of advice about these kinds of questions. We've already done this, so we don't need this here. But when you have a debt question like this, the first step should always be to solve for n, that is time, where future value is 0. and to get a feel for where the crossover happens. And I'll show you why this is so important. So we've got Steve or Kevin here. Kevin's scenario is more straightforward. We've already done this, but there will come a point at which Kevin's debt is reduced from $32,000 to zero. That's right. That's the sort of time frame we're working on. And we said this morning that that was going to be 8 years and 8 months. So we already know that. Here's where this gets to be a challenge. And here's where you can really go badly wrong with a financial calculator question concerning debt if you don't position yourself properly before you start. Your financial calculator doesn't know that this is a credit card. Your financial calculator just knows that is a 19.99% interest rate and $650 per month. So if I run this thing where I continue paying $650 a month after that 8.8 year, or after that 8 years and 8 months, what does the calculator think is going to happen with that $650 at that point? Yeah, that's it, Melanie. And what return does it assume that I'm making on that investment? Okay. Yeah, that's exactly it. So the calculator will assume 19.99% after this. Okay, which is wildly inaccurate, right? This is exactly not how credit cards work. Does everybody then see why I would suggest that the first thing to do with any debt question is to solve for that time where the credit card will be paid off? Is everybody with me here? Because otherwise, this effect can be very confusing. Now, we already know that that's 8 years and 8 months. We don't have to do this. We've already done this for Kevin. Okay. Okay. That's all good? All right. So now we can bring up the calculator. And that is the kind of thing when people don't do that, then they get very confusing answers. Okay. Now, actually, I don't have to do the whole calculation again. I could just do, and this might be what you did, Mike, I'm not sure, but I could just do this. I could do P1 and P24, right? Using the same variables I had from before lunch. And then look at the balance, right? I don't have to go back and redo the whole calculation. Should we do that? Okay. So you see the benefit of the amortization worksheet. Again, it makes this kind of thing relatively straightforward once I have the worksheet built out properly. Okay. So then what's my next step? Where should I go from here? Yeah, now before I even do that, yeah, I've got a new IY and all that kind of stuff, but what's the first thing that I should do? Draw a line. And I don't want to lose sight of that, right? In fact, I could have drawn both lines to start. Okay. So we're going to put in, that's it. We're going to put in our present value here at 28,584. Now we know 7.5%, no longer 19.99%. What's the payment here? So still $650 a month, beautiful. And what's my N here, or my time? That's again what we're trying to compute. And future value, 0. Okay, so now we can go through PY and CY again are going to be 12 times PY. We're going to compute, or we're going to solve for N. IY at 7.5. Present value is 28,584. Payment negative 650. Again, I have to get my positives and negatives in good standing here. And my future value, 0. Okay. So I do have to redo the time value of money calculation now. I could get a little clever here, but I prefer not to. I'm just going to clear what I've got and start over. So again, same thing. Kevin already got $28,584 worth of, I don't know what he bought in this case, Melanie, Netflix subscriptions and whatever else he's running on his credit card. Okay. All right. So if it's negative, it's money that he's putting somewhere. That money has already come to him. Okay. Or looking at it this way, Melanie, it's gone from 32,000 positive after a couple years to 28,584 positive. It's still money that moves or is moving in the same direction as when he started, right? You're right. When we solve back here, okay, Melanie, when we solve back here, this is why we're drawing a second line, because we're doing a second calculation. In fact, wasn't that 28,584? I don't think that's exactly what I said, Melanie. I think you're sort of framing something I said a little bit different. Okay. No, even if this was the credit card, okay? So let's say that the scenario here was different, Melanie, that Kevin is now paying $850 a month on his credit card. He could do $650 for 2 years and then $850. I would still start the same way. The 28,584 is still a positive here. It's still already money that he got. It's money that he put into his pocket. Okay. Okay. I can't remember exactly. I know that I did comment last week that the positive and negative for debt repayment questions is the most difficult. Okay. I'm sure that I said last week that when you start repaying a debt, the present value is positive, right? Is that what you're thinking of here? Yeah. Okay. So when on the green line, the green and brown and red on the right side, okay, but hang on a second, that's not the same thing, right? That's a new calculation. Okay, I can't go a month into this and then suddenly the amount's negative because the calculation changed.
Okay, sorry, too much typing. I literally have the notes here where it says outstanding balance, money that came to me to buy TVs and all that good stuff. So equals positive. And then I have pay down balance. Once you've been paying down balance equals negative. And lower outstanding balance after some time equals negative. And I've starred that
Yeah,
because that was a point that we all were very confused about last
right.
week.
So that's still the same. I'm not changing that. That's what this is, right? So this
Well,
28,
then why isn't the present value of 28,000 negative?
because okay, so there's always been a point at which, like, Kevin didn't just wake up one day with $32,000 of debt on his credit card, right?
I don't know. I don't know what Kevin did, to be honest.
Okay, but that's not even possible, right? You can't just, I guess, I don't know if you have a credit card with a $32,000 limit, I guess you could, but most people are going to have spent a bunch of time accumulating up to that level of debt, right?
Okay, I'm just saying that what we discussed last week, and I've written it down, is not what we're talking about today. So I'm just confused is all. I have remember trick, first borrow equals positive, after start paying off equals negative. So
Okay, so really, okay, so maybe first borrowed isn't the exact right language to use there. The point is that whatever you're starting from for your time value of money calculation, the outstanding debt is positive. So this is my first, I have a time value of money calculation here. And this is part of the point of drawing two lines, right? So this is the first time value of money calculation. So it's just what I said last week, right? The debt at the start is a positive, right? And the payments are a negative. Agreed?
Yeah.
Okay. So then in my second time value of money calculation, it's still the same thing. In the context of this calculation, it's still true that the debt at the start of this calculation is positive, and the payments are a negative. And I haven't changed that. That is what I showed last week. Now, we're gonna go through the calculation in a minute here, Stephen. The future value here, it's assuming there is still future value, right? The future value is going to be a negative. Yeah, it's true. Esther's right that you don't want to focus too much on that negative, especially if you did what I told you to do down here first. Then you're always going to know that if you get a balance here, that it's an outstanding balance, right? So that's where each draw a line exercise, Melanie,
Sorry, I just have a real problem with it being a different conversation from last week because now I'm all turned around. So can you then rephrase what we were talking about last week so I can get it straight in my head?
So how about if you said for each time value of money calculation instead of for each debt payment?
Okay.
Okay, because that's really what it is.
When you're partway through paying down a debt, would the present value be negative?
If you didn't do the first step that I showed you down at the bottom here. Oh, you can, that would never happen. You can't have that with a debt. There would be no point, there would be no point where you could be paying off a debt when present value could be negative. Because then it's not a debt, right?
Okay, I'm just going to pull up the chat from last week because I think I know I'm not the only one that's confused about this. Okay, we can move on for now.
Okay, I mean, you asked me to rephrase it, and my rephrase is accurate here. So we can, yeah, go back and bring up the chat from last week. That's fine. I'm curious to see what's inaccurate there. But this is an accurate way of stating it, that for each time value of money calculation, this is true. Okay.
Okay.
Yeah. Okay. Yeah, it's true, Alicia. You're exactly right. the future, and that's what I have in orangish here, right? In the orange, future value. I said, oh, sorry, Melanie, you're still off mute there. So the future value is going to be negative because Kevin would still have to pay $28,584. That has not changed. Okay. Yeah, I don't know exactly. I guess I need to see the quote or whatever. It's okay. I think context is significant there. All right. So yeah, that's right, showing that he still owes that. Okay, so let's go to the second part here, the 7.5% component. All right, and this is where we're going to set our PY and CY again to 12. Oh, sorry, I should do a clear all at the start. Clear time value of money. All right, now we'll set our PY and CY to 12. Okay. Yeah, and that is the point here, Robert, is that each calculation is really its own calculation. So it's not like I can calculate something and then say, now that I've calculated that, that changes the entire life of the rest of how I would calculate something, right? Okay, so my PY and CY, all right. And then we're gonna do 7.5 as my IY and 28,584 as my present value, 650 as my negative payment, 0 in future value, and we'll leave this on end, and then we can compute, and we get 51.58 months. Now, somebody already pointed this out. A couple of you, I think, already pointed this out. And this is a very common thing. So this is where, and I think, Cam, you asked a question like that this morning. That answer is going to be there. Okay, so the exam questions are going to give you answer A will be whatever 44 months. Answer B will be 52 months. Answer C will be 60 months, whatever. And answer D will be 76 months. Okay, or it might be months and years, however, right? Okay, and what's the correct answer here? It's D, right? It's actually D because the question is, how long until today, until his debt is paid off, which is the 52 months you see here, plus the 2 years you see back here, okay? Yeah, it's fine. Second compute is just fine, Paul. I'm not fussy on that at all. Okay, that's a perfectly valid way to do it. Okay. All right. That's good. Okay. Yeah, now to be fair, if I'm telling Kevin, if I say, Kevin, don't worry about it, your debt's paid off in 52 months, I am badly wrong, right? I've tricked myself and probably tricked Kevin too, okay? I really had better say, Kevin, it's going to be 76 months. Okay. All good? All right. Is that what it is, Todd? Good stuff. Okay. Yeah, well, I don't think it assumes it. I think it says it, Esther. I think it's the only way to read this. If he gets his credit and spending in check, he will refinance in 2 years, right? How long from today? Yeah, I don't think there's any other way to read that. Okay, that's all good. Yeah, and I think honestly, Mark, and I hate to say it this way, that we trick ourselves. That this is really what it is. Okay, thanks, Stephen. It is a matter of we can build all sorts of little tools to trick ourselves into doing things wrong. If an exam is well written, if it gives you sort of good relevant scenarios with an appropriate amount of information, I find just people will misapply that information or whatever the case is. So this is where we do want to slow down, make sure we understand the equations we're doing. We'll be okay.
Jason?
Yeah.
Can I just read this to you? Because maybe a bunch of us
Do you want to share screen? Do you want to
Yeah,
share?
that would be awesome.
Yeah. Just
Okay.
give me 1 second here.
Okay.
Yeah, you should be able to share your screen now.
Okay, perfect. So we start talking about it here. Bonnie and I had said positive for the debt balance.
Yeah.
And then you had said like, no, actually it's negative. And we said, oh, weird. And you explained it. We said, oh,
Right.
weird. And then Bonnie said, well, like, isn't it positive because you still have the balance? And I said, well, it's still money that you have spent on TVs, etc. So yeah, wouldn't it still be positive? And then Esther says, first outstanding balance is positive, but last one is negative. And then, and I said, yes, exactly. And then, Paul says payment on credit card is negative.
Right.
And then, anyway, if you scroll down a little bit, Esther says at 15, 55, 53.
Yeah.
Okay, so when you first use a credit card to borrow, it's positive. After you start paying off, the balance is now negative. So, that's what I understood
within,
too.
Okay. Within the context of that time value of money calculation, right? So when I go to a second calculation, like we did just now with the Kevin scenario, then you're really back to the start. So here, just give me a second.
Okay.
That's good. Okay, so this is all in the context of one calculation, right? So this is for one sort of TVM cycle or for one draw line. Okay, and then if I'm doing a second draw a line, now I have to go back to the beginning and start over, right? So for a second calculation, again, same thing. The balance at the start is positive, right? Money came to you, that's still true. Your payments are negative, money is leaving your pocket. And if there's still a balance at the end,
I am not
it will be
understanding
negative.
how these two things would ever be in the same one equation. Like it's either a positive or a negative in one. There's only one spot for a present value, and it's either positive or negative. So I don't understand where there could be a situation where you're doing two, credit balances, one that started in the beginning and one that started later. One is negative, one is positive. So
Yeah, you
I'm
can't.
still not.
So it's always positive. You're right.
Well,
So
that's not what that says.
okay, where do you see where a present value is negative here? That's what I don't understand.
That's what we were asking over, and a bunch of people jumped in and said, well, hold on, like that doesn't really make sense. How is that possible? And then Esther confirms it there, what we're all thinking. Okay, so when you use a CC in the beginning at first, when you first get all the money and you've bought your TVs, is positive. But once you start paying it off, the balance is now negative. And so in the example that you were just showing us, we're at a point now where he has paid it off for 2 years.
So I guess I didn't understand if that's how you interpret Esther's question. You and I interpreted it differently, and it's obviously Esther's question. So after you start paying it off, the balance is negative. That's the future value in the calculation. That's what I assumed that she meant. So because we hadn't gotten to two-stage calculations here yet, right? So this is the negative in the future value spot.
Well, that's interesting because the example that we used right after, because I write down everything, it was a negative $6,000 investment present value. So it wasn't under the future value.
That question wasn't a debt payment question, though.
It was all about debt. This is incredibly confusing.
You can see it right here. This calculation right here, this $6,000.
Mm-hmm.
That's the one you're talking about, right?
Yeah.
Okay. That was not a debt question.
So now it's different whether it's a debt question versus a retirement question?
100%. That's right. And when we did this last week, right? So here, I can bring up last week's notes and show you this. That was the exact context here. Remember I said context is everything? So just bear with me for 1 second here. That was Intro to Financial Calculator. Okay.
I just don't understand how that could be misinterpreted, because it says when you first borrow, it's a positive, and that can't be a future value amount. So that would only be talking about present value. The borrowing amount is present value. It's not a future value.
The amount, okay, so if I have a line of credit, for example, right?
Mm-hmm.
On which I owe $10,000.
Mm-hmm.
You with me here?
Mm-hmm.
And I'm paying, I don't know, whatever, let's say $300 a month for 2 years. Am I going to get that $10,000 line of credit paid off after 2 years?
No.
Okay. So can I use the future value to solve for what I still owe after 2 years?
Sorry, I'm reading the slide. Just give me a moment, please. Outstanding balance positive. You get all your toys. Pay down the balance. Once you start paying down the balance, it's negative. Lower outstanding balance after some time is negative. These amounts both have to move the same way to get to zero. So these both here then, are you saying these negative numbers, once you've paid down, was not referring to present value at all, was referring to future value?
Right, yeah. Okay, just like in the scenario I just described. I started at $10,000, right?
Mm-hmm.
I pay whatever I said, $300 a month for 2 years. At the end of it, I still have a balance outstanding, right?
Yeah.
Okay.
We're gonna have to talk about this later, because.
But that balance outstanding,
Mm-hmm.
if I solve for it, it's going to show in my calculator as a negative. And then if I did
I'm too confused right now. Can we just move on, and can we talk about this another time? Because I'm sorry, my brain
I'll
is
answer
officially
whatever questions come my way.
flustered and not working, because.
Okay,
Let's chat about it another time.
And this is the $6,000 question. This is not a debt question, right? This is a mutual fund question.
Yep.
Okay. Okay. Oh, I don't want to go here. I want to go here. Okay, so that's it for the Kevin question. All right. And then we already did our retirement planning questions, so I want to go to, oh, sorry, I don't know where to go. There. Okay, so this is a different example of a question where we have what is a reasonably close to real life scenario where we're going to, yeah, I mean, that's good move, Paul, right, is to free up debt so you can take on more good debt, right? We're going to work through a little bit of a thorough example here with the post-retirement benefit. So do we remember roughly how the post-retirement benefit, oh, sorry, this is not my PRB question. This is my delayed CPP question. All right, so anyways, we're going to do this one. So do you remember how delayed CPP works? So what happens if Nabil says, I don't want to start CPP at 65? Okay, so he's going to add 0.7% per month. Now I've already given you that calculation, so you don't actually have to worry about that because we're told he's got $486 a month if he starts at age 65, or $809 a month if he starts at age 70. So we've taken care of the extra 0.7% per month. Once I know those things, what's the question we're trying to help Nabil solve here? Yeah, you should know the minus 0.6%, Esther, and the plus 0.7%. Those are numbers you should know. Yeah. Okay. So clearly the $809 a month is more than $486 a month, right? Would everybody agree with that? Okay. However, what does he have to sacrifice to get the $809 a month? So what's he sacrificing to do this? Okay, he's going to go 5 years without the 486, right? Agreed? Yeah, and that's exactly what we're going to try and figure out here, Mark, that break-even point. And what's the other thing that he has to do in that interim 5 years to make this work? He has to contribute. Perfect, Stephen. That's right. So plus pay CPP premiums. Okay. So, and Bev, it's a very common question, isn't it? Especially for somebody like Nabil, who is quite shy on his amount of CPP income and says, you know, really, that's a big difference for me. Should I work the extra 5 years? Now, I'm going to ask, I think, what's a fairly obvious question. So if Nabil dies at 68, at age 68, what was the right decision? Then he should have started at 65, right? Notwithstanding any survivor benefits or whatever the case is. If he dies at 72, what was the right decision? Probably 65, right? But if he dies at 85, what was the right decision? Yeah, that's harder to know, isn't it? And in fact, that depends, Mark, is going to at least to some extent depend on our calculations. And that's going to be part of it, Todd. Yeah. We're going to bring that factor in here to some extent. Okay. that all good? So sure, let's draw a line. That was a good recommendation. You know, I'm a big fan of that to get us started. Okay. So what do I know on my line? We're going to, Paul, yeah, hang on to that thought. Okay, so we can look at age 65. What else could I put on this line? $486 a month. Okay, so we can do this to age 85 to 20 years out. That's right. What's going to be the future value? 0. Now, why 0.7, Sean? What's your rationale for 0.7? That's just the question we asked here, Todd. I said 85. I just chose an arbitrary year. Okay. Well, I don't have it in this calculation. I know what you're thinking of, but that's a different question, Sean. All right. Okay. So this is actually a fairly difficult thing to determine. This is where I want to use a discount rate that's appropriate for Nabil. Okay. And the question here really is, what's the value of $1 to Nabil today compared to a value tomorrow? Okay. So if he's investing it, that's easy. Let's say, just for the sake of argument, if he's investing and earning, let's say 5%, and inflation is 3%. Everybody's with me here? Actually, do inflation at 2%, sorry. So if he's investing and earning 5% and inflation is 2%, then I would say his discount rate is 3%. That's the rate, that's how much more $1 is worth today than it is a year from now. Okay. So it's sort of an artificial calculation. There's a fair bit of assumption that goes into your sort of personal discount rate. And we're going to talk a little bit more later on about how to use a discount rate. I still would suggest that most people, Sean, are going to have some sort of a personal discount rate. And we could potentially use a psychometric analysis to figure out Nabil's discount rate, but it really is the question of how much more is money worth to him if he has it in his pocket today versus if he has it a year from now. Okay. Is that fair? So we could talk about opportunity cost here. I think it's easy as well to overthink this, to get it exactly right. And I think for most people, it's really going to be somewhere between 2 and 4%. Somewhere in that ballpark. Okay. Now, let's say that he was carrying a massive amount of consumer debt. So let's say he were carrying whatever, thousands of dollars, I don't care how much, of credit card debt, and I know his CPP will go to that. Now, I don't actually know that his CPP will go to that. That's a giant and probably very dangerous assumption. But if that's the case, and let's say he's paying interest at 22.9%, okay, that's probably true, Mark, right? Although maybe he'd be in the same bind if he had, but if he's paying interest at 22.9%, now what discount rate would you use? This is where I would use, at least until the debt's paid off, a 22.9% discount rate. Okay, that's good. 100%. Perfect, Mike. That's exactly where I was just going to go. If he's got a mortgage and you know he would pay off that mortgage, then I would use the interest rate on the mortgage as his personal discount rate. Okay, that's good. Everybody see why? Yeah, so that's the tougher one, Bonnie, and that's where I would go back to my 2 to 4%. That's probably about what it is. So discount rate, Stephen, normally where you see discount rate used is in actuarial calculations. Okay, so it's a term that actuaries use to say, what is the value of a dollar today compared to the value of a dollar tomorrow? Okay. So you also, well, all the life insurance folks anyways, life insurance is a great example of where discount rate shows up big picture. Okay. Yeah, so I did give myself that sort of unusual assumption, Paul, right? Okay, because it's not the same as inflation. Nabil isn't just growing his wealth by inflation, or he's not going to discount things just by inflation. Okay, and let's look at life insurance for a second here, Bonnie, right? So you've sold a couple life insurance policies in your day. One, all right. So I'm going to use term to 100 life insurance policy. It's a very easy example to see this with. So term to 100 life insurance is a permanent life insurance policy with little or no cash value. Okay, for those that don't know it, it's just permanent insurance, means it's going to be in force until you die, and then it pays its death benefit. That's it. So if I have a client who is, let's say, who's buying $100,000 of life insurance. Okay, you with me here? This person's going to buy a $100,000. Yeah, that's true, Carla. That's it. That's exactly it. Yeah. Or he's going to get that return on his dollar. Okay. No, that is not, that 0.7% is not the discount rate. Okay. So that 0.7% is just the increase per month in your CPP. Don't confuse those two items. Okay. Okay. Yeah, it literally, so I know it's not an easy concept, Esther, but it is that. It is how much more is a dollar worth if I have it today than if I have it a year from now. Okay, so I'll ask you this question, Esther. Maybe this is an easier example. Would you loan me $100 today if you knew that I was going to pay you $100 back 12 months from now? And that's exactly what I'm going to pay you. I'm going to pay you one. Okay. So at least as far as you and I are concerned, you don't like that deal. You might want $105 or $110. I don't know what amount you'd want, but you're not going to settle for $100, right? Is that fair? Okay. So you're saying $100 today is worth more than $100 is a year from now. And some of that might be inflation. So Esther, what if I said, I'll pay you back that $100 plus inflation? So I'll pay you $100, and then a year from now, we'll know what CPI was. It'll be super easy. I'll be able to pay you back $101.40. Is that enough? Okay, so we're getting there, but we're not there yet, right? Okay. So the same thing happens with our $100,000 of life insurance. Let's say you have a 50-year-old client with projected mortality at 90, those could be the same actually, Sherry. Okay. Okay, so that's a different way to solve this problem, Bonnie. And it leads to a similar outcome, but it actually isn't a solution to the problem. And I'll show you why in a few minutes. Okay. No, it's not what we're doing. No. Okay. We're going to think about this like a retirement planning problem. Okay. Yeah, we'll come back to that in a second. So I've got projected mortality at 90. Is this client, so that's 40 years, right? So if we do $100,000 divided by 40 years, that'd be $2,500 a year. Will the premiums be more or less than $2,500 a year? So if you just choose the amount above inflation, Robert, that would be a real rate. Again, that answers your question, I think, too, Sherry. If I choose the amount gross of inflation or inclusive of inflation, then that would be the full discount rate. So I can take my discount rate and then make it a real rate. Okay. They would. You're saying those premiums would be more than $2,500 a year, Esther? They're going to be less. Yeah, they're going to. Somebody can run a quote for me if you want, but I think you're going to find your premiums here are going to be about maybe $900 a year. I think that's about what it's going to be. Somebody want to run a quote on a healthy 50-year-old male? Okay, right. So they are able to discount that $100,000, Alicia. They know they're going to pay the $100,000, right? Or at least in about, with permanent insurance, in about 97% of cases, they're going to pay the $100,000. But they discount that based on what they can earn on their investment returns, Alicia, and inflation is part of that, right? Okay, so that's all it is. It's a rate of return. Okay. Sure. Okay, that's good, Cam. I can live with that. Still about the same, right? It's not $100,000. It's well short of that, right? Okay. All good? So the term discount rate is pretty complicated, but when we get to see in practice, this idea that we know that dollars today, we'd rather have a dollar today than the same dollar a year from now, right? That's all discount rate is. Okay, can we go back to Nabil now? And I'll answer your question, Bonnie, I promise we'll get there. Okay. So we're going to assume here, I'm going to use a 3% rate of return or a 3% discount rate. Okay. And that might be based on a 5% gross rate of return with 2% inflation. I'm pretty comfortable like that. I think that that's going to be pretty representative of most retirees or near retirees. Yeah, so Robert, what I might actually say here is a 5% discount rate. You with me here? 2% inflation, so then a 3% real rate. It's still a discount rate. I've just discounted my real rate to inflation. Okay. Good. Wait till we get the pensions. Holy man. All right. Good. Okay. And again, I don't think I have to be overly detailed here. I think as long as I use something that sort of make sense. I'm talking 9 or 10%. I'd have to have a pretty compelling reason to use 9 or 10%. Okay, so all right, so the PY and CY, what's my PY going to be here? How many payments per year are happening? It's 12. What's my CY? Yeah, probably 1. Probably fair. Annual compounding is probably more accurate here. Times PY? 20. IY? 3. Present value? So this is what we don't know, right? We're going to compute our present value. Payment, 46. Positive or negative? Is that coming to him or going away from him? It's coming to him. And future value? Zero. Okay. So let's crack open the calculator here. Okay. Melanie, I know what it's like to be frustrated, and then are you with me here, Melanie? Are you okay with this? I get where you kind of left off there. I hope you're not lost on this exercise, because this is it's an equally difficult concept. So okay. Yeah, okay. Yes, absolutely. Shay, that you would be, if you need to solve something like this on an exam, you would either be given the discount rate or you would be given enough information to determine what the discount rate is. Okay, that's good. Okay. So okay, so the first part of this here, we're just going to go to PY and CY. Now we're going to do our PY at 12, enter, and our CY at 1, enter. Okay, get out of here. We're going to do 20 as our PY. Don't forget to hit N, sorry, as our times PY. Don't forget to hit N. So I should see N equals 240. Get 3 as my IY. I got 486 as my payment, 0 as my future value. I don't want to be on begin, and I am not. And then we can compute our present value, and Paul and Stephen agree with each other, which is a good sign. And that's where we get 87,952. Now, what does that 87,952 mean? And this, Bonnie, is what you were asking about. So what I'm suggesting here is that this is the approximate value of 20 years of CPP for Nabil at $486 a month at a 3% discount rate. Okay, that if I was telling Nabil what his CPP is worth, That's what I would express it to him as. I would say, really, the government of Canada is giving you a benefit that's worth about $88,000 by doing it this way. Okay? It's very much like an annuity question or a retirement planning question. Okay? Oh, what'd you get, Ksenia? Or how much different? Oh, so I think that, Ksenia, you forgot to hit N. That's almost certainly what happened there. So just try this. Don't do a whole reset, right? Try this. Give me 20 second function times py. Come on, times py, and then hit N. Try that. And then compute your present value. See what happens there. Let me know if that fixes it, but I think that's what it is. I think you forgot to hit N. Okay. That's exactly the benefit of solving for present value, Bonnie. It allows me to compare to otherwise dissimilar cash flows. Okay. And by the way you would have known that, Ksenia, is, man, it's funny, Andrew, is you could have done a recall on your N, although you would have had to know where you made your mistake. And I would wager if you did recall on N, you got something substantially less than 240. Okay. Okay. Nice, Andrew. All right. Oh, that's crazy. Okay. So however it was, Ksenia. Oh. So you don't have it then. All right. So I would go back and redo it. We'll go redo it together. So second function, py. We're going to start over here. Okay. We're going to do second function, clear time value of money. Clear. We're clearing everything. I'm starting over from scratch. Okay. Good, Robert here. All right. And we're going to do second function. Robert's way ahead of us now on pension calculations. We're going to do second function py. We're going to set our py to 12. Enter. We're going to set our cy to 1. Enter. So now I just want to have a look and make sure they're right. My py is 12. My cy is 1. Quit out of there. 20. Second function times py. N. So do you have n equals 240 up on the screen? Perfect. And now we're going to do 3 IY. We're going to do 486 payment, 0 future value, and compute present value. Okay, good stuff. So there's a whole bunch of stuff we can consider here. So yes, let's ask Robert's question. What if we had a higher discount rate? So what if we used a 5% discount rate? What if it turns out that Nabil could actually get better returns with his invested dollars? Okay, that's good. So we're just going to relatively quickly here plug that in. We say at a 5% discount rate, plug 5 into the IY spot and compute our future value. Sorry, I apologize. I want to redo that. I want to compute our present value. So 5 into the IY spot. And compute our present value. Okay. And that brings the value down for the pension. So yes, Robert's quite correct here, or for the CPP benefit. So at a 5% discount rate, it's only worth $74,331. Okay, is everybody with me there? Everybody see why Robert made that conclusion? And there's a very easy real life place to see this today. What's the big criticism of annuities today? What's the reason that a lot of people are turned off of annuities. We're in this very low interest rate environment, and therefore I need a ton of income. Sorry, I need a ton of cash to buy a good annuity, right? So this is exactly what causes the phenomenon that Robert is describing here, is that a lower interest rate means that cash flow is worth more, and a higher interest rate means that cash flow is worth less. Okay, no, it's not return on other income, Stephen. It's really just, we've really calculated the CPP benefit on its own right. Okay, just by itself. So now I'm going to just go back to my 3% discount rate and resolve my present value. Okay. Sorry, rates don't go down, Philip, or what doesn't go down? Once you buy them. That's what you mean with an annuity. Once you buy it, doesn't go down? Yeah, once you buy it, right? But an annuity today is going to be less generous. It's good, isn't it, Stephen? Is going to be less generous than an annuity that you would have bought 10 years ago, Philip. Is that a fair comment? If you have a client who bought an annuity 10 years ago, they're probably grateful that they were able to buy that annuity 10 years ago. Okay, that's all good? All right. Now, can we anticipate, it really is, Stephen, right? Okay, harder to come by, right? Can we anticipate what else Nabil might ask here? Can anybody anticipate what he might ask instead of if I live to 85? Yeah, around 2.7 or 2.8%, Andrew. Depends on your age, but sort of at the late 60s, early 70s, about 2.7, 2.8. Okay. Yeah, he might. Now 70 is obvious, Sean, right? We decided 70 was obvious, but that type of hypothetical might still show up here. Is that fair? Now we could talk about tax consequences. Paul, I don't want to go down that road yet because we haven't done any other tax work, but you're right, that might show up. Okay, so that's kind of what we're going to get to here, Mark, right? So now let's look at just a couple of other hypotheticals here. Sorry. A couple of other hypotheticals, which would be, what if he lives to 80? And what if he lives to 90? And what changes if I do those hypotheticals? Yeah, we're going to do the 70 in a second. Mark and Shade are both raring to go for the next step, but I'm not quite ready to get there yet. Okay. So if he lives to 80, let's look at 80 first versus 85. So now my times PY is 15, or my times PY is 25. Would everybody agree with that? And Ryan, this is sort of like the exercise you had us go through last class when you asked me to do a couple hypotheticals, right? While we were looking at a real scenario or looking at a question. So same type of thing here. So I'm just going to plug in 15 into my times PY spot, and I get 180. And now I'm going to resolve my present value. Okay, so if he only lives to age 80, now this decision was less valuable. Would everybody agree with that? Okay. And then by extension, what do we expect if he lives to 90? Be a more valuable decision, right? So that's where we can do that same thing, 25 second function times PY, and we can resolve our present value. Okay. Okay. Yeah, so all I did here, Andrew, nothing fancy. I only had to change the one variable, right? So I just did 25 second function times PY and then N, and then I compute the present value. Okay. Now, do you want me to do the whole thing, Andrew? Because I'm perfectly happy to do that. Yeah, okay, no worries. Do you want me to do it with age 85 or with one of the other ages? Okay, perfect. So we're going to start from scratch then. We're going to do second function, clear time value of money, clear our work, clear everything. We're all clear, right? So yeah, I promise we're getting there, Mark. Yeah, I know we're getting there slowly, but we're going to get there. Okay. You're right, Cam, assuming the real return never changes. Yeah, so we're still going to use 3% here. I did exactly, Sean. I used 3% all the way through. So now we're going to bring up our PY menu. We're going to do 12 into the PY spot and 1 into the CY spot. Okay, that's good. So my PY is 12, my CY is 1. Then I do 20, second function, times PY. Don't forget to hit N, so I should see N equals 240. Okay, I got 3 into the IY spot. I got 486 into the payment spot, 0 in the future value spot, and then we can compute our present value. And we get 87,952. Okay, good, Andrew? All right, perfect. Okay. Yeah, that's right. That's exactly what it is, Stephen. That's exactly what we're trying to figure out, is what has to happen for this to be the right decision, or at least, yeah, now I could say, Shade, you're right. The negative is not a big deal here. I could say what I'm asking is, how much would you have to spend to buy an equivalent annuity? Okay, if you really want to see an interpretation of negative that makes sense there. Okay, so Melanie, yes, I appreciate this question. At a 5% return, you're going to get more dollars for every dollar you invest, right? Yeah, perfect. So if the markets are generating 5%, I have to invest less to get a source of income than if the markets are only generating 3%. Yeah, perfect. Okay. No, the HP calculator is just as impacted with negatives and positives, Andrew. It's exactly the same for negative and positive. Yeah. Yeah, so that's exactly what I did, Rosalind. When I did the lives to 80 and lives to 90, all I changed was the times PY value. Yeah, you're quite right. So I did. All I did here was where I had 20, I just plugged in 15, right? This is what you're looking for, Rosalind. And then I did a compute present value. Yeah. Okay, good. A little experimentation here is quite useful. I quite like it. Okay. So now, Mark is chomping at the bit here for us to get to the second part of this. Okay, so Now let's do our second time value of money equation. So what do I know on my second? Draw a line. What do I know here? Okay, I know the payment, Philip, and that's going to be 809, right? We're starting at age 70, Alicia. That's perfect. Paying to age 85. So now 15 years. Okay, again, same discount rate, Alicia, right? Makes sense. What's the future value here? Big fat 0. And we can go through and solve this again. So our PY is going to be 12 and 1, same deal, times PY is going to be 15 here. IY is going to be 3. Present value, we're going to compute payment at 809. Future value of 0. And I guess I should just be clear here, say we're solving all of this on end. Your CPP payments are made at the end of the month. Oh, excuse me. Okay, are we ready to solve that? So again, we can clear and start over. So same, I'm just using the same discount rate, Robert. Still, I'm assuming that Nabil is in that same situation. Okay, it really is just an eyeball sort of rate of return or comparable to the rate of return he would get, and real rate of return here, because CPP is indexed, the real rate of return he would get if he went and invested on his own. We could have used 2% or 4% or whatever, but it's usually going to be somewhere in this relatively low range, somewhere sub 5. Okay. All right. So the PY here, again, 12 in our PY spot, and then 1 in the CY spot. So again, I'm so much eyeballing it, Andrew, that I don't really care that much about it, honestly. It's a very, very approximate calculation here. Okay, this is, is it Warren Buffett? Better to be approximately right than precisely wrong? Yeah, it's a fair point, Andrew. I'm more concerned about it in a calculation where we're trying to solve sort of an exam style question. Okay. All right. Oh, so Alicia, hang on to that thought. You're absolutely right, but you're a step ahead of me. Okay. That is a big deal. At least I think it's a big deal. Okay. So we then do 15 years. Okay. And IY of 3 and $809 of payment. And then 0 future value. And then we compute our present value. Okay. And we get a whole lot larger number. Our present value is $117,479. However, what age is that true at? When will that be true? That's true at age 70, assuming he starts his benefit then and lives to age 85. That's the present value of his CPP benefit. If he starts at 70 and lives to age 85. Is that okay? I think they are, Stephen. Yep. Yep. This is a very similar thing that you might do in a commuted value discussion. Okay. Although we won't actually do that calculation for a very long time, but we will do that. Okay. So this is it. So Sean and Alicia really have the, sorry, Sean and Alicia really have the same point here. And that is, no, that's the next step. Assuming everybody understands where we are now. He had to do both, Andrew, right? Okay. Well, so far that's true, Bev, but we have one more step to do here to confirm that. So really what we want to do now is take that value at 70. So we know that his pension is worth $117,479 at age 70, but we know that over those next 5 years, he's going to have to continue participating in the Canada Pension Plan. Okay. So here we are, age 65, and we're trying to compute the present value here, or solve the present value. Okay. We use that same 3% discount rate. That's, I think, the safe thing to do here. But yes, his CPP premiums are going to show up in this. Now, we don't know, Robert, so now that would be easy to get. If we really have Nabil as a client, we will know how much money he's making. Is that a fair comment?
So Jason, even if he did, like, even if he just deferred, though, he still gets 6 or 7% a year, right?
It's 0.7% per month is the increase. So, and we already have that worked in here, right? That already shows up in the difference between the 486.
Oh, okay, that's where I'm. Okay.
Yeah. So there's no extra math to do there, and it's not a time value of money calculation, right?
Okay.
Yeah. Okay. Perfect. So it's a lot of numbers that get thrown around here, isn't it? No shortage of numbers. Okay. So yeah, we're pretty close to the max. We'll just use 2,600 mark, might be 2,500, whatever, but we're in the ballpark there. So exactly, Sean, 2,600. We'll assume that's his CPP premium. And of course, that's indexed, right? That amount will grow to keep pace with inflation. And again, we've used a real rate of return, so we're okay with that. Okay, so now PY of 12, CY of, let's say we're going to do PY of 1 here now. CY of 1 times PY will be 5. IY 3, present value, we're going to solve. Payment is 2,600. What way are those CPP premiums going for him? That's going out of his pocket. And now this is another one of these ones where the positive and negative is maybe a little bit counterintuitive, but he's really going to get the $117,479 when he's 70. And then in a separate time value of money calculation, he would turn around and invest it back into his CPP, which I know isn't really what happens, but that's how we're going to use the time value of money here. So why 5%, Robert? I'm not sure what the rationale is for using 5 versus 3.
Well, I was just thinking in this question, what we're trying to kind of figure out is, to me, the way I've been looking at it is, what amount would we want to take at age 65 to equate 117,000 at age 70? If I take the money at age 65, I could invest it at 5%, not 3%, based on this.
Is it a risk question, or are you taking inflation out of that?
Maybe just keep going with the example, and if I still have the same question at the end, I'll ask.
Yeah, I think that in order to be consistent, I have to use 3% all the way through. He's still the same investor for this entire 20-year span. Now, maybe you could work a scenario in here where you say, well, because he's still working, he could take a little more risk. Maybe I don't know if I want to do that, but I could buy that argument. I just don't want to go down that path here if we can avoid it. Is that fair? But yeah, maybe with Nabil, we say still working, so he's going to let his investments ride a little bit more. Who knows? So future value is going to be 117,479, and it's going to be a positive. Okay. Yes, that's right, Steve. Yeah, the 3% is 5% minus inflation. That's the sort of eyeball figure that we use there. Yeah. So I have to use my zoomed in calculator now. All right. Just I'm out of room. Okay, so we're going to, I'm actually going to clear everything here. I don't have to. What I could do with this is I could hit the negative and then dump that exact number into my future value spot. Everybody's with me there? If I'm using the same present value from before, I can now put that into the future value spot. I just have to be careful when I do that, because now when I go to my PYCY, I have to remember to still change all of those things. Okay. So then 5 years, interest rate of 3, 2,600 negative as our payment. That money is going away from him. 117,479 will come to him, sort of, at age 70. I'm on end mode, and I can compute then my present value. And for him, that's $89,431. And that $89,431 means, or what we've really calculated here, is that if he delays his Canada pension plan until age 70, so if he at age 65 delays CPP to 70, pays 5 more years of premiums, more than you ever thought, eh, Andrew? If he delays his CPP to 70, pays 5 more years of premiums, okay, that this is worth, his CPP benefit is worth approximately $89,431 today at age 65. Okay. It's kind of the case, isn't it, Stephen? You don't want to be sitting there watching all this madness happening, do you? Okay. So he still has a premium to pay over those 5 years, Sherry, right? He's still working. That's part of what increases his Canada Pension Plan benefit. I assumed it. I did assume that was his CPP premium. It's right around the max. Sherry, I think the max this year is $25.89. Okay. Sorry, what? You're missing a word in that question, Todd. What does that number at the end mean? Is that what you're asking me? Yeah. So I would say to Nabil, this is how I would phrase this. Okay. I would say, Nabil, if you decide to start taking your CPP today, that this is about the same as the government of Canada writing you a check for $88,000 based on this number over here. That's good. But, Nabil, if you decide to wait 5 years and then take your CPP benefit, it's about the same as the government of Canada writing you a check for $89,000 today. So you're about $1,000 better off in these sort of notional terms to wait 5 years to take your CPP. Yeah, it's not a very compelling argument, is it, Esther? Now, if there's some other tax implications that might change this, so that's it, Todd, right? If he dies in the next 5 years, he gets nothing, okay? Conversely, what if he lives to 95? Then the decision to wait was the better decision, wasn't it? Okay, so this is where we'd want to talk it over with Nabil. We'd want to figure out what risk we're more concerned with. Are we more concerned with the risk that he dies when he's 75? Or are we more concerned with the risk that he lives to 95? Okay. Yeah, I mean, definitely the more assets you have, Esther, the easier these decisions are. Okay. But this is a real thing, isn't it? Not every client we have shows up well equipped for retirement. Is that fair? And I think Sherry at the beginning of, Sherry or Bev, I can't remember, one of you at the beginning said, this is a very real problem. This is something people want to know. Okay. It is complicated, Todd, isn't it? Okay. Yeah, now do you see, Ryan, where you could do a sort of Monte Carlo analysis here, right? So I could say, well, if he lives to 71, lives to 72, lives to 73, and so on, I could show the chance of dying at each of those ages. But in the end, I don't know until he dies what the right decision was. Okay. Yeah, now the problem there, Bonnie, is if he retires and delays his CPP, the $809 isn't true, right? Then you're working on a smaller amount. Yeah, taxes are a big part of this, Andrew, that we just haven't discussed yet. I don't dispute that. So because I'm not just concerned about CPP, Robert, what I'm really comparing this to is not inflation, but really what would Nabil do with those dollars? Okay. Okay, Nicole, that's sorry about that. That is just funny how you phrased that. All right. Okay.
Mind if I ask my question again, Jason?
Yeah.
So if I have $89,431 today, and I looked at this as an investment option of which one would I rather have, shouldn't that work the same? So if I have 89,000, I know I'm feeling like I can go get a 5% return on investment, which is why we use that as a discount rate. When I use that number, it gives me a future value of 128,505, which is not the 117. So I feel like those two numbers aren't necessarily equivalent, the 89,431 and this 117,479, based off of this equation. I feel like the 5% is what I could get. So I would actually use that number in this example. It's a bit
Okay, but you're not really going to get 5%, right? You're going to be 5 years later, and what you made over that 5 years is going to have less purchasing power, right?
Yeah, but the 117 isn't adjusted for that.
It is. It absolutely is. The 117 was because I used a real rate of return for that last 15 years as well, right? So when I did this calculation.
Okay, so the 117 value, maybe this is where I'm confused. The 117 value is in today's purchasing power.
It's in purchasing power starting at age 70. And then by using a real rate of return, I brought it back to purchasing power at age 65. But I still have to use that inflation adjusted purchasing power starting at age 70. Right? I would suggest that I've equally applied inflation for the entire span of this problem.
Okay.
Okay.
So that 117 value is not the value that they would have at age 70 then?
No, I would say that's right.
It's the value that they would have at age 70
in inflation adjusted dollars.
Inflation adjusted from age 65.
Yeah, that's fair. Yeah.
Okay. All right. Cool. Thank you.
Yeah. Okay. Yeah. So, and this is perfect, right? So everybody has kind of come to the same conclusion that the math is only really one part of the story, but it does not give us an overwhelming win one way or the other. And that's what it should be. Okay. Keep in mind the Canada Pension Plan is designed by actuaries, right? So the actuaries say the same thing you do. They say, yeah, this plan's going to make sense if you live after your expected mortality. It'll have made sense to wait. And if you die before your expected mortality, it'll have made sense to take it early, right? That's the same actuarial principles we're going to see all across this course. Okay. And yes, taxation. Is he still working? Does he need the income? What will he do with the dollars?
The government also change it as well, Jason.
Sure. Might the rules change? Yeah.
Well, if you're collecting, you're still getting it. And if you're not, well, now we're going to change something. You never know.
No, it's possible. Now, I would be surprised. We talked about this with OAS last week. I would be, or 2 weeks ago, whatever that was. I would be surprised to see a change to a plan like CPP, especially because it's funded, where it actually impacts how much people are drawing today. The changes we've seen here have typically been, they have always been, here's a change, and it's going to really take effect for people some point down the road. Okay.
Jason, in the exam, we've been around with real rate of return and discount rate and inflation. It's a case. Will it be very clear? Like before, we were saying, well, we'll just use the 5%, and then all of a sudden we started to go and use the real rate of return, which was 3. Will it be clear to us in the exam? Because are they going to just give us a case study and say, okay, solve for, no.
The exam is going to be relatively prescriptive with what numbers and values to use, just like you see in the practice question. So some of you have done the Pearl practice question already, for example, and there's no doubt what IY you're using in that question or what you're solving for. Okay, that's good. So Sherry, it is possible to calculate that break-even age. However, it's not an easy thing to do on the financial calculator. Now, we've actually come pretty close to it here, haven't we, Sherry? Right, 85 might very well be Nabil's break-even age. Okay, what tool could I use to calculate that break-even age if I really want to do that? That's where Excel comes in. Yeah, Excel is far better for that kind of calculation. Okay. Good. All right. So I'd like to take our coffee break there. Yeah, you could, Sherry, those scenarios, you probably looked at, we're going to look at that spreadsheet after the coffee break, right? Did you look at a spreadsheet that had about, what would it have? It's, I think 90 Excel calculations on it, or 90 time value of money calculations on it. I think that's right. Yeah, so you could do that on your calculator, but do you really want to be doing 90 calculations for every different hypothetical scenario? So again, that's why Excel is so much better for that kind of thing. Yeah, perfect. Let's take a break there. I have 31 minutes past. Oh, sorry, Stephen. Let's try that again. 31 minutes past. Take a 15-minute break. And we'll resume at 14 minutes too. Okay, thanks.